This is the exponential growth and decay day 2 video, which is just a continuation of day 1. So please take out your calculators and let's dive right in. Number 1 says a highly contagious virus outbreak hits Rochester with initial number of 10 sick people. Ooh, I like how it says initial, and I'm going to highlight all that stuff. It says the number of infected people doubles each day. So if you're thinking what I'm thinking, doubling means multiply by 2. Yes, this is exponential growth. So A says write an equation that models its situation. They tell us what our y value is. In this case, our y value is P of D. So let's put that in here. So P of D is going to equal the initial number of people. So we start with 10, and what happens every single day? Well, it's doubling. We're multiplying this 10 by 2. And I could show this multiplication all the way through by 2, by 2, by 2, by 2 every single day, or we can just write a D in the exponent. All right, so B says how many days? So how many days? Oh, it's asking us for D. Will it take for the wording is weird, so for the entire city to be infected if the population is 211,000? Well, this is weird. So we're looking for the X value, and they gave us the Y value. I think this is a job for our calculator. So let's head over to our calculator and let's graph it. Okay, when you first graph this, the things that I want you to be careful of is making sure that you are using X's, even though we're dealing with P of D's and D's. Remember, your calculator only understands X, so I've typed into my calculator 10 times 2 to the X, and then we are looking for a Y value of 211,000. Okay, these are kind of small, like 80, 160, 320, okay. Oh, now we're getting into some large numbers here. And as you can see, we are getting very close to that 211 on day 14, and by day 15, the entire population of the city will be infected. So when does this actually happen? We would say, I think the best way to say it is between days 14 and 15. Oh, that's an and symbol. Okay, number 2, Pat. He gets a new Jeep Wrangler for his 16th birthday. It was $40,245 brand new. Initial value I'm looking at right here, but depreciates. So I'm hoping that you're thinking, oh, it's losing value at a rate of 6.5% every year. Okay, this is definitely exponential decay because we have a multiplier, but this multiplier is a little tricky. So remember, when we see percents as multipliers, we always want to compare them to 100%. If we have to write an equation, which is what we have to do in A. So write an equation that models this situation. If the value of the Jeep, V of T, can be represented as time goes on, so T for time. So when we write our equation, we write Y equals, in this case, V of T equals what we start with, so our starting value of the Jeep. And what happens to the Jeep over and over and over again? Well, we're multiplying it by something every year, so something to the T power. Well, what is that something? Well, that's where our percent comes into play. So 100% minus 6.5% is 93.5%, but we can't use percents in our equation. We have to move our decimal place over 2 spaces to the left to write this as a decimal. So 0.935. All right, now part B is asking how much less will the value of the Jeep be from year 3 to year 6, and then round to the nearest cent, which is really the hundredths place value. We have a couple options. We could do this algebraically, or we can use our graphing calculator to help us with these calculations. I'm going to head over to my graphing calculator and graph this function, which I've already done here. So I graphed my function. Again, remember we have to use X instead of T. And then we want to look at year 3 and year 6. So here's year 3, here's year 6. It's being cut off a little bit, so we want to get these numbers that are down below here. So when I go to my paper, I'm going to write 32896.27809. And then for my year 6, we have 26889.40, nope, 4300-4-ish. And since we're trying to compare these two, we are going to subtract and find the difference, which I have done here for us. And when we subtract those two, we get 6006.84805. But if we need to round to the nearest cent, that means we want the hundredths place value. So what is the difference? That would be $6,006.85.